Go ahead and go live. Okay, hello everyone. Welcome to this live stream, my third one for the day. This is incremental language design for Wolfram language. We've got a variety of topics here. GeoPositionPicker is up first.
Right, we have Brett here to discuss it.
Okay.
So the cloud team has asked for a functionality to interactively select a location.
Okay.
And so these already almost does it, but it's not perfect. So
the question is, what is the language level interface to this? But I mean, they probably want something that can be deployed in a cloud form, right?
Right. I think that they will use their own maps, etc. But they need the symbol and the syntax.
Okay. So
I was gonna say, do we have a cloud person here? It just occurred to me.
No, this was just Carlo asked us to discuss it here.
Okay, but so what are the comparable functions? I mean, it's a setter function. We need somebody from the front end team here. I don't know how the setter function, how does date setter work, for example?
That's the new date setter being selected.
Yeah. I mean, is this going to be a pop-up thing, or is this going to be a thing that works in line?
That's an interesting question. I was thinking of it as being a thing that would work in line, but I mean, I suppose the new date selector, the date setter thing is a pop-up as well.
Is it?
Jose?
I don't remember. I've seen it, but I don't think it was appear.
I mean, you didn't see the full calendar the entire time, did you?
No. It's not something that shows a calendar. It just shows a menu, and you can select the number of the day, the number of the year.
I have a bad feeling we do not have the right people here to decide this. I mean, we need people who know about the design of dynamic controls.
Mm-hmm.
Right? I'm sorry, yes. I don't know. I mean, I can go to the page.
I was expecting we would discuss the implementability from the geo side, because I think they expect us to implement this thing from our side as a variation of dynamic geographics.
But I think we probably need to include front-end people, and we probably need to include cloud people, because they probably have some idea of what they expect it to look like on the cloud.
Mm-hmm.
And if desktop is we don't want to diverge too greatly from that.
I mean, I don't know whether it's a setter or whether it's something else. I mean, these are pop-out type things. Also, there's the question of the drawing tools, mechanism. Where we have a molecule drawing thing that can pop out. Wrong people here, I think. I mean, and who's actually going to do the implementation?
I think this requires two separate implementations, and one probably based on something like dynamic geographics, which is probably for us, the geo team, and another one in cloud. They will have their own maps.
Right. But I mean, I'm assuming that this is basically going to be a version of dynamic geographics that allows you to have. So, I mean, this is more like, let me look here. Presumably, it's more like a locator. Well, is it like
and the one that you're
pane?
moving around right now is locator pane on top of dynamic geographics.
Right.
I mean, it's also kind of like color slider, possibly. so you have color setter and color slider. And one of the differences between them is, so whether it's a pop-up thing or an in-place thing.
Right. I mean, I'm kind of thinking it's some sort of geographics pane, because I can imagine a case where you actually don't care about the locator, right? Where basically what you're doing is you're trying to capture, you just have dynamic geographics without any locator there at all. And you're just trying to say, okay, go pick the part of the world you care about. See what I'm saying? So you're going to preserve the center, the bounding rectangle, because that's information as well.
I
See
see.
what I'm saying?
Mm-hmm.
Yeah, could be even the country.
Yes.
Like that.
Yeah, right. Which, and yes, and you're right. You could also want to select something bigger than just a point. So I think it requires some design there, but I'm kind of thinking that geographics pane or geoposition pane, or even just geopane, might be a possibility.
Perhaps geolocation pane, if it's going to return things other than geopositions.
Yeah, okay. Or geolocator pane.
Mhm.
Yeah, I mean, maybe this is the right answer. Geolocator pane just contains the analog of the XY there. And, that's probably the right thing. Maybe it was something you had already suggested here. I think geolocator pane is the right idea.
Mhm.
That would be my suggestion for the design.
Okay.
All right,
And
next, go ahead.
No, I was gonna say, the dynamic first argument stuff is pretty easy to do. So to get stuff out like locator pane does.
Mm-hmm.
So cool.
Okay.
Enjoy your tree designs.
Thank you. See you later.
See ya.
Bye.
Okay. So this is
So Billy?
Yes. So we kept the green selected highlight from last week, and Ian had provided some nice examples for content, which we were lacking in last week. And so there's 3 sort of color options to try to get a feel of we're going in the right direction or not, all away from yellow.
yeah, I think these are pretty decent. I'm going green. I'm feeling like going green here, so to speak.
Stephen, Billy pulled me into this, but I didn't understand the different coloring for the selection highlight. Does that mean it has some different interaction when you interact with the content?
This here?
As opposed to graphics or graph.
Well, it's a different kind of thing, just like graph is a different kind of thing. In terms of interaction, I don't think it has much yet.
Okay.
But this is mostly indicating this isn't your average graph. It's a tree.
Okay.
Now, yeah.
Does that mean it will have interactions that are different than graph? Why is it different than graph visually? Why is that important?
Because it's a different kind of concept. I mean, it really has very different structure. A tree, just to be clear, I mean, a tree, all you have to say is what it requires less information to specify a tree than a graph.
Okay.
I mean, you'll like trees as soon as you
Okay.
meet them. I mean, they're not quite the same.
Yeah.
And actually, one big difference from a graph is the payload of every node is important. On a graph, it's just an annotation, but here, it's very often important. Like, we could make what am I saying? We could make this family tree. They really not have children over on this side. I didn't know that. It shows my paying attention to the anyway. I think maybe that tree just wasn't filled out properly. Maybe not. Maybe they're okay. In any case, no matter. What's my point? My point is this wouldn't be a very exciting family tree if there wasn't a labeling on the nodes.
Mm-hmm.
Now, unfortunately, the labeling in the nodes, it's kind of unfortunate that we have this double border here.
We don't have to. I mean, that's a choice we make for entities, but it's do you want it visually distinct from, say, a label when it's a known entity?
Yes, because most labels don't have their own framing. Most labels are just, the word hello, so to speak, and then we do want a box around it. Yeah. It's just in these cases of double boxing, I don't know what we do about those. Okay. Let's take a look at this. It's kind of dull, this one. Boom. I don't think we should go as bright as this. I think it'll get annoying. I think
Mm-hmm. Feels like you'd add your own color if you need it, but this was at least connected back to the selection highlight.
Yeah, I mean, I think my preference would be this first one. I don't know. What do other people think?
I also prefer this one.
Okay. Well, I think this is the winner.
Would it be weird to add some greenish color to entities? Or do they need to stay in the yellow family?
I've gotten used to them being yellow. What we mean in this case?
Yeah, as used as a label.
Oh yeah. I don't see why we can't do that. In here, we can if we're recoloring these, we can do whatever we want. I mean, yeah. I would say in a tree thing, just break open the cell wall, so to speak. There's no reason to have a double border here.
Okay, just spill the color into the whole.
I'm thinking,
frame.
yeah. I mean, but of course, what happens if there's a list of 2 entities in there? Then you're going to need the entity thing again. I don't know whether we can do this. I mean, I don't know whether we can have it break the cell wall only when it's right there in the container.
Yeah.
Do we recolor entities in other places? I know dataset does it. But are there
through style
places?
sheets? I'm assuming it. Well, I don't know how it was done in dataset, but it was, and I think it's controlled in a style sheet.
All right. Well, my point of view is, if we have to have a border here, just have it be a really light green.
Mm-hmm.
So it will fit in here. I mean, look, maybe within this environment, it could just use essentially that green color there, that background color there. And then, then it's going to look more like this, which is just fine. Somebody needs to be on mute, by the way, who isn't?
Probably me, sorry.
Oops. I am using a new browser today, so I'm going to have different wrong behaviors. Yeah, okay, fine. All right, seems like a thing here. Oh boy. I don't know. I mean, all these corner cases of things like this, I think the generic entity one we should probably worry about. We shouldn't worry about any of these other cases.
Yeah, okay.
Okay, this one here. What do we want to do about the rounding radius for a really big, a big node? What would happen if we made it a more rounded? Would that look good or would that look stupid? That's probably not going to work in these corners.
It is more rounded though. He's done that, right, Billy? Or have you?
I don't think they are, no, but I could.
Do you think it would look sensible, guys?
You mean to make the distinction clearer between inner nodes and leaf nodes?
No, I just mean that I think this big slab of green is a little weird, but I don't really see how to fix it. I mean, I think it's
I mean, perhaps it's just that it should be smaller itself.
Oh, I see.
In
Which
this
has
case.
nothing to do with, yeah, right. That's the right answer. It has nothing to do with graphic design. Don't worry about the graphic design. It's just a bug in the rendering. Make sense? Ian, does that make sense to you?
Yep.
Okay. Yeah, I mean, in other words, you should try to keep it so that anything like this is as small as it can be while not having the elements crash into each other. That would be my suggestion. Any composite node is shrunken as small as it can while not having its subnodes crash into each other. Does that make sense?
Yep.
Okay. All right. That was it for that. Okay. Onward. Why do I think this is going to be a complicated discussion?
It is, and we started this discussion in a previous meeting. And this is and do you want to look at this first?
Why don't we look at this first? It's a bit smaller.
Yeah, so this is a function that was suggested in a recent meeting. It's a function to snap numbers to a grid. And I'm not sure at that point we were referring to the computation itself or to the type setting, and the type of do not show all these additional digits. But so this is referring to the computation. So how to snap numbers to a grid.
Right. I think it's a good concept.
Yeah, this could be useful. Now, the thing is that round almost does it, except for the fact that it requires numbers to, the grid to contain the zero.
What is it? What's this last argument? So the round normally
Right. So it's some sort of multiple, which is aligned with all other members of this family, like mod, quotient, etc.
Okay, so what does it do wrong?
The problem is that what happens if one wants the grid not to contain zero? Like, for example, I only want the grids of all 0.5. So
I see what you're saying. This thing is a ruler with equally spaced items on it. The round thing is a ruler with equally spaced items, as opposed to.
Well, we do want that, but it's a ruler that contains zero. So what happens if we don't want zero? It's like mod. What happens if mod we want it from minus 180 to plus 180, not 0 to 360? So mod has this third argument, which is very flexible, very useful. And the point is that round, floor, and ceiling do not have that third argument.
Again, explain this to me. So what would it do for? Okay, for.
So imagine that we want this grid that only returns numbers which are 0.5. How would we do it with round? Because if we say round x is 0.5,
yeah,
it's going to give 0, 0.5, 1.
Right.
So we would need a round x, 1, 0.0. Sorry, 0.5.
Right. That's the second argument is the delta x, and the third argument is the offset, is the x0.
Exactly. And to make it clear that this is a perfectly reasonable thing is that all these 5 functions can be written in terms of each, for example, in terms of floor. So you see here the 5 functions written in terms of floor. And they all have this combination of x minus x0 divided by a.
Yeah. Seems to me to make sense. We should just have an offset for each of these. But now, yeah, okay. So there probably isn't a role for snap.
Right. If this is what snap was supposed to do, then I think this should be the natural generalization. Now, of course, if we want a multidimensional case, then that probably requires a separate function. Like, for example, min max is to coordinate bounds or range is to coordinate bounds array.
Mm-hmm.
So this is something we have explored a few times in, well, a couple of times in ILD, the idea of having multidimensional generalizations of these numeric functions.
What's the point of that?
Well, you may want to have, I mean, imagine you have a table of data, and each of these columns needs to be snapped to a different grid. So we want to control the grid independently.
Why aren't you just doing a round? I mean, so you're saying instead of, I don't know what the listability of these is. This right now, these are all going to be independently handled, right?
Mm.
Right. I mean, if I have a look. Yeah, it'll just listabilize over that.
Right. But what if we want a different delta x for each dimension?
So right now, at least for this will probably work, right? But that wouldn't work if we had, the question is, it's again, one of these things that's like the broadcast problem.
Right, exactly.
I think we should think about solving a problem like this using that mechanism of inserted, or whatever we're going to call it.
Okay.
Potentially. I don't think it's a big enough case to, that's where I would go with this initially.
Mm-hmm.
All right, let's go jump on the trees. Go climb the trees. Okay.
So our main problem here that we haven't solved yet is if we want to map, do we map to the payloads or do we map to the trees? And how do we distinguish? I mean, both operations are useful, and we just need either separate functions or a way to specify one or the other in a given function.
All right, what is map going to do? What's map on its own? What could map on its own do? I mean, we believe that map on its own will, the most consistent thing to do based on associations would be to map onto the payloads.
Right. And I think that's our default, right? Ian?
So tree map maps onto the payloads, and tree map node maps onto the substrate.
No, but what does map itself do?
We asking what should it do? It doesn't do anything.
At the moment, it doesn't do anything.
Well, I think it should. Why wouldn't it? I mean, on association, it does something, right? Do I need prototype builder head branch?
Prototype.
Okay, why shouldn't ordinary map do something here?
In a sense, map would have to interpret the tree as some particular expression. And so we have this function called tree expression that allows you to construct various things, or and there is the opposite, expression tree, which interprets expression. So in a sense, it will require a choice of interpretation.
Right, so map on a graph doesn't work, right?
Right.
On a graph, I would expect it to map onto the values if it did anything.
Mm-hmm.
I think it's the only reasonable thing for it to do. And I do think that will be a reasonable thing for map to do on a graph. And arguably something we should have happen. So, I mean, what I would favor is that tree map maps onto subtrees. What does association map do? Right. Yeah, this is directly analogous. If tree map maps onto subtrees and map just maps onto payloads, I think we have something consistent.
So a couple things with map, like it has this option heads goes to true that is kind of specialized to expressions.
Thank you.
And the other
hold on. Let me think about that for a second. Well, I mean, heads goes to true doesn't do anything terribly interesting in association either, does it?
I don't know.
Well,
No idea. It's a good question.
Puffle. That's what I thought it might do, actually.
Interesting.
What would be the analogous thing in trees? I mean, this is in the category of not terribly useful, what's happening there, but probably consistent. Okay, anyway, I think map should go on the payloads. Okay, tree map should do
so the other thing with map is that its default level spec is level 1, and tree map's default level spec is 0 to infinity, which is more useful for trees.
Well, map all is 0 to infinity, isn't it?
Mm-hmm.
But it's not obvious that that is the right thing, because I mean, it might be that you want to map onto the leaves of the tree. Right? I don't know how often you'll want to map onto leaves versus onto the whole tree versus onto subtrees. So you're saying tree map would map onto every level of subtree?
By default. It also takes a level spec.
What was this fed? I don't understand why this says F of A. Or is that?
A was the payload of the root.
Oh, okay. So this is doing payload mapping here, which is not what we want. Right? This is doing the opposite from what we want. This is doing what we want map to do. Correct?
Yep.
So by default, map would just map onto level 1 in the tree, correct? Level 1 is the top of the tree, correct?
No, it's the children.
Wait. Is that level 0 there?
Yes.
Oh boy. We don't have a level 0 for ordinary map, do we?
We do.
It is the whole expression.
Oh, okay. Fine. Then it's consistent. You can't have a tree that has multiple roots, can you?
No.
Not
Yeah,
for us.
so then it's consistent. Then map. Well, I see. Consistent. So it's gonna slightly bizarrely, it would map onto the one level down. Right?
Yeah. Also, I don't think that mapping onto the payload is really like what map is doing. Map is more like mapping to the subtree.
How do I go from a scary tree to a tree?
Do trees backtick, or actually no, just graph tree of that should work.
What the heck is that? Oh, that's because you don't have tree visualization yet. When are
Right.
you getting that? When is that going to be the default?
We're building it right now.
Okay. All right. Okay. So there it is. So now what are we asking here? We're saying, what's the analog? So we're saying it will be tree map. Is it right? I'm trying to map onto, or is this tree map taking sub-expressions?
Tree map will be the payloads.
Right now it's payloads. Is that correct?
Right now it is payloads. You want %4?
Okay.
Map node.
What the heck is that?
So you can't really tell what's happening because there's just data structure blobs there, but each one of those is the subtree at that particular node. Do like F at star tree rules.
Tree rules or tree visualization?
Tree visualization should be fine. Well,
Except that it isn't.
yeah.
That's really funky. Okay. Okay. So what you're saying is the default here would be normally. What the heck? Why doesn't that work? Level 1. Why doesn't that work?
Right, level specs are not implemented at the moment.
Okay.
But there will be.
Yes. I took them out to put in breadth first scan and haven't put it back in.
Okay. Well, it's a little bit unclear to me. Okay. So my initial take is that map should go to the payloads and tree map should do the subtrees. Okay. And that map all is what you would do if you wanted to map onto the whole tree. Make sense?
Mm-hmm.
I mean, I could imagine wanting to map onto the leaves of the tree, but these are all, I don't really know what's going to be common there.
Well, so that could be just level -1.
Of course. Well, list -1, because level -1 will go up the whole tree. Right?
Level -1 is specified with list -1.
Yes, correct. Okay, all right. So that's what I think, that's my provisional suggestion here. So now, how does tree fold?
Tree fold, instead of having two different functions like we had for tree map and tree node, and tree map node, it has a optional argument.
Okay, hold on. Three, what do you mean different functions? We're saying.
So tree map and tree map node are the two different behaviors we're talking about.
Yeah, right.
Tree fold can do both of them, but it controls it with an optional argument rather than by having a tree fold node or something.
Why doesn't fold just work with the graph?
I mean, fold is for lists.
What does fold do on an association? It works just fine, doesn't it? No, I'm not buying this. I'm sorry. I'm not buying it because then there's going to be other issues like.
I mean, maybe tree map and map could be argued to be the same operation, but tree fold cannot be argued to be the same operation as fold.
What does tree fold do?
It's the thing that replaces So you have all these nested trees, and it replaces each use of tree with a function.
Why isn't that tree apply?
I mean,
That doesn't strike me as treefold at all. What you just
we only barely got to discuss this a little bit last time.
Okay, fine.
A generalization of fold, like fold as a higher order function in functional programming. It'll depend on what the data structure is that you're trying to fold, and list has a particular folding operation.
Okay. So look, the problem is this: fold implies a successor function. It's some kind of iterator with successor, right?
Yep.
And that just doesn't exist on a tree without a traversal order. Right, so I think what you want here is tree apply. And that's the thing that would turn this tree. I mean, yes, that is an interesting operation. The operation that turns the tree.
And it's not just apply, it's like recursively applying to every subtree.
Look, here's a case that comes up in real life. Okay, we've got a tree. It has unlabeled nodes except its leaves. Okay. Do you want a real example? I'll give you a real example.
I can imagine that.
Actually, I'll give you an example that just came up. There it is. Okay. So the way this works is it's a tree, and you start off by putting ones in all of the leaves, and then you put an operation F at every node, and you propagate that up the tree. Do you see what I'm saying?
Interesting. So this is folding from the leaves.
Yes. I mean, I've needed this operation. I'm sorry?
Which is what treefold does. It's a post-order depth-first traversal of the tree.
Okay, but so this is something where it's replacing the payload here by the combination of the payloads at these leaf nodes. And it's recursively doing that. But it's ignoring every payload that isn't. Well, I see. If it's a 2-argument function, it could take in this payload here. What is it doing? No, I'm totally confused now. Look, there's a thing that is applying itself to all the children of a given node, right?
Right.
And that's what this is doing. And then that is recursively applying itself to the children of a node.
So it's recursing from the root towards.
From the leaves to the root. Now, what did your operation do?
So it also goes from the leaves to the root. But it's not like just apply it. I mean, one thing is it's not for mutating a tree or modifying the tree. It's for reducing a tree to a value.
Right.
But I think this is an important operation. For example, imagine an R tree in which we have many nested rectangles, and we have to find out whether a point is in one of the rectangles. So the typical thing would be to start at the root and descend through the branches to find out whether it is in one of the branches. So isn't this a natural threefold?
Well, that's a different issue. Yeah, and that's one way you're saying.
I think that's not a folding operation because you don't care about the sub expressions. It's like an ordinary map. You're traversing the tree.
It's not just a map, though. It's a path find down the tree.
Yeah. But it doesn't simultaneously need all of the information from its subtree to do that. You're just walking through the tree and making a decision.
Mm-hmm. But the decision depends on what has happened in the previous node, right? As we go down.
Yeah, the parent needs to know if there was something found in the child, a child.
Look, it seems to me I'm a little bit confused because given, in this case, any given element has any number of children, right? Which are given in its tree. I forget now whether it's the first or second argument. Which one is it?
The second argument lists the children.
Okay. And the first argument is the payload.
Yes.
So really, this is a three-legged creature. No, maybe it's not. Yes, it is. No, it isn't. No, it isn't. It's a two-legged creature. So what you're saying is, at any given stage, say our tree fold takes a function f and a tree, and at any stage it takes f of current payload and child results, right? And that's what it returns. Is that what you're doing?
That is exactly what it does.
Why is there an arrow there? FA arrow, whatever. Shouldn't be an arrow.
Where are you seeing an arrow?
Right there.
No, that's because the function was composed with tree rules.
I see.
Tree rules put the arrow there.
Okay, I'm not agreeing with this. No, that's got the tree data structure there. That's not what I'm saying. Look at what I'm saying. Look at what I'm saying.
Well, because
saying,
the optional third argument was specified in that example that you copied. Or was it? No. Oh, this is tree map node.
Oh, this is something completely different anyway.
And so, yeah, I guess that's not going to work because tree visualization doesn't take two arguments.
I'm totally confused by this, but okay, but you see what I'm saying. This is what I think it should do, and it sounds like you think it should do that too.
That's basically the usage message that I wrote.
Okay, then I agree with that. There's no third argument of anything. It's just that.
Well, the third argument is a function that you apply to the subtree before you give it to the function. And by default, what it's doing is getting the payload. Like this is saying f of payload, comma, the results. And the third argument lets you do something other than have the payload there. In particular, you could have the subtree there. And so that's
I don't care about that case. Well, unless I'm missing something. But okay, so I don't object to the third argument, but I don't particularly care about it. No, this looks pretty good, although what this is going to need for the leaf thing, for the thing where you're going up from the leaves, is it's going to need a function where if that's none, you do one thing, and if that's a particular value, you do a different thing. I mean, in other words, how do you get this started at the leaf nodes? What does this do?
So at a leaf node, it uses an empty list for the second argument. That was kind of more of a finer design point of how does this even treat non-terminal leaves and terminal leaves differently? Should there be a different function for the leaf? And I erred towards just having the one function, since you can use multiple down values for F to have it.
I know, but I think that it might be convenient. Look, if treefold were able to take functions f and g like this, that might be nice.
Yeah, my thought for that would be that G would just apply to the payload of leaves.
Exactly.
And F would be a binary function.
Exactly. What?
Internal subtrees.
Yep, exactly. Yeah.
Which, it does make some programming simpler.
I think so. Like the thing I want to do back on that other page, it would just be G would be 1 ampersand and F would be something on #2.
Right. Whereas right now you have to pretty much, if you want to treat the leaves differently, then you have to define a function F and give it multiple definitions.
I know. So this is preferable.
Yeah.
Okay. Very nice. All right.
So this was after the discussion of map versus tree map, and you wanted to know which other functions would.
Okay, what is tree replace? Why is it different from replace? Or replace? What does tree replace do? Does it replace subtrees or payloads? And what does replace do on an association? Nothing. Okay, replace all replaces the payload. What would happen if I said A goes to 1 here? Nothing. Okay. So I suspect replace all should work on trees and replace payloads.
I mean, so one thing is for trees, we want to be able to have a tree whose payloads are patterns and then use that tree to pattern match with another tree, which is,
So,
I mean, that's just not what replace does.
I understand. I think that's a place where you can use tree replace to pattern match the tree. Now, pattern matching the tree is the kind of the quintessential XSLT operation, isn't it?
I'm not sure.
Well, we need to make sure that those operations are clean.
Mm-hmm.
But I think, I mean, I would say replace all replaces payloads. Tree replace does subtree replacement.
I see. So the general idea is that the existing functions act on payloads, the new functions act on trees.
Yes.
I see. So the positional functions for which we want to have an extended tree relative notation, I mean, we can
like
implement
position,
that.
for example, operates on payloads. Position is asking, where is that payload, isn't it?
Yes. What I was thinking is that imagine position in a tree.
Position is not looking for the payloads. It's looking for subtrees.
Oh. But how do you look for payloads?
Somehow that would be find me positions, but only if they are used as heads.
Horrifying. Why isn't position? I mean, to me,
Like what we have with a tree corresponds to a whole expression. And so all of our normal functions like map, like if you map at level 1, you apply the function to the whole expression at level 1, not just the heads.
But that's not what we're saying should happen, right? We're saying we should apply it to the payloads.
I'm describing how it does work currently
I
for
understand.
expressions. Yeah.
I think we need to try more cases. I don't have a good feeling for what's going on. Okay, but we do need a principle that, for example, position, I mean, to me, doesn't position work on payloads in associations?
I think the general principle in association is by imitation of a list. And
see that works there perfectly well for payloads.
Right, but what is the analogy of a tree for us?
I think it's an association with some kind of, I mean, okay, so one way to think about a tree, it's just an association with a collection of progressively longer sequences of coordinates. Am I making sense?
Yep.
And if we thought about it that way, then our natural, whatever is
How is tree an association? Like it's like a rule whose right hand side is an association, or
no, I'm saying that the tree is as if it's 1 goes to element, because every element in a tree has a label, right? So 1 goes to whatever, 1 those are the tree coordinate positions.
So
The
this
things
is a
that
mapping
would-
of positions to payloads.
Yes,
I see.
which arguably is a form that we should allow as a way to make a tree, which I don't think we have right now.
No.
So I'm claiming that's a possibility. Okay, hold on. Look, what does free Q do on association? These are flatten. How do you get a list of all the things that are in payloads?
Tree data would be the way.
And what do you say in tree data?
Well, so tree data will have a second argument that's the same as extract, and it extracts the payloads at the positions that you give it.
Sorry, say that again.
So tree data is like tree extract, except that instead of extracting the subtree, it extracts the payload at the position that you specify.
Okay. When am I going to get to play with all this stuff? And when is tree visualization going to be built in?
We are working right now on it. I'm hoping that in the next few days.
Okay, fine. I think we're going to need to have more discussion here. And I think you need some cases, just like you did for the thing that Billy was showing, of actual trees, right?
Mm-hmm. Yeah, we do have some examples already of various sizes of trees.
Right. Okay. Bev on the live stream says, each time an initial condition generates a subnode, the subnode becomes a new function independent of the functions that generated it. And the final nodes are equivalent functions of all previous functions. That's a way of generating a tree from a function. And that's yet a different kind of operation. That's an operation where instead of generating fold list, you're generating a tree. It's a fold tree as opposed to a tree fold.
Well, so there's nest tree.
What does that do?
It's you apply a function to
Oh, I see. It's like nest graph.
an expression or to each leaf node in a tree, and then
Yeah, that's nice.
Yeah.
Yeah, it's like nest graph, except that now what happens? Except the tree
it's
can
like
never
nest
merge.
graph, except that it only applies the function to leaf nodes, whereas nest graph applies the function to every vertex and yields a new graph.
Wait a minute. Nest graph takes, yes, all existing vertices and gets their successors connected to that vertex, but then merges vertices that end up being the same.
Yep.
Whereas here you're not doing that.
Yeah, we will, like if F returns 2 at 2 separate positions in the tree, those are not going to get collapsed so that it stays a tree. And the other difference is that we don't apply the function anymore to anything other than leaves. So it's just growing the tree from the leaves.
Right. All right. Well, we're making progress here. I think we need to play with some more things to know that. I mean, I think you have a definite idea of what you want to do with this. I mean, I'm not certain that I'm right about this tree map thing and so on. So if you want to just go ahead and implement whatever you think you should implement, if I haven't convinced you that what I'm suggesting is better, implement whatever you think is best. That sound reasonable?
Okay.
I mean, I still recommend, whenever it can be modeled on association, model it on association.
Yeah, I think that the main principle we learn from association is having a conversion model that we already know well. In that case, it's a list. And
Right.
So here, I mean, we have been working on the assumption that trees are almost expressions. So what we can learn of the function working on a general expression should be imitated for the tree.
I think that's right. Yeah.
But this difference of tree versus data does not exist in expressions, and that's where the model breaks.
I know, where the payload, I mean, an expression, you could have a payload hidden in the head, but we're not really, there are a few head games that we tend to play.
Right. I see. So that's, yeah. So we have discussed other times functionality for operator forms and things in which the heads are nested. And yeah, there we get immediately to the idea that we need patterns and we need various things for that case. So it might be related.
Right. That's true. Yeah, that's true. All right. We should wrap up here.
Mm-hmm.
So good stuff. All right.
Okay.
Talk to you.